Well, with this ellipse, the first thing that I'm going to do is draw a picture so I can get a visual grasp of what's going on. So it's 100 yards long at the widest, so that would have it going from -50 to 50 for the widest, and 20 yards at the narrowest. So on the y-axis, have it go from -10 to 10 for a total of 20 yards. And then an ellipse. So this distance from the center to the longest part is A, and this distance is B. And so as an added bonus, we can come up with the equation for this ellipse. It would be x squared over a squared plus y squared over b squared equals 1, or x squared over 2500 and y squared over 100 equals 1. That wasn't asked for in the problem, but it was just extra fun. The problem is actually asking for the focus point. So there's one somewhere in here. They have to be on the main diagonal or the longest axis. So they're approximately right here and right here. Well, the distance for them is called C. And then we'll use the formula that c squared equals a squared minus b squared. Can't be plus because the c is actually smaller than the a, so you have to say, all right, start with a squared and it's going to be smaller than that. Or the way that I remember is when this is plus for an ellipse, this is minus for the focus. And when this is a minus for hyperbola, then this is plus. Okay, so anyway, we've got that c squared is equal to 50 squared minus 10 squared. So that's going to be 2500 minus 100, which is going to be 2400. And then we need the square root of that. And because I need to find out where on the graph this is, I'm going to find the decimal approximation. Square root of 2400 is approximately 4899. So C, 48.99. So actually I should have had it more about right over here. And so then find the focus points. So that's going to be the one on the right is 48.99, 0. And then on the left would be negative. So actually I could have just said plus or minus, and there's foci, or the focal points.